Guys, I'm going to go over the 5 questions that I posted onto Google Classroom after you finished your first Edpuzzle. I'm going to show you how to walk through each problem because these were some emails I was getting, a little bit of confusion here and there, so I want to hopefully clear that up for anyone just so you feel more confident moving into what we're going to be doing that requires us to know how to simplify radicals. So I'm going to clear this and get started with our first problem, which was the square root of 45. How do we simplify this? Well, so if we had the square root of 45, we can break that down into 5, which is prime, and 9. 9 can get broken down further into 3 and 3. So then we can rewrite the square root of the square root of 45 as the square root of 5 times 3 times 3. And we'll see, is there anything that's being squared? Is there anything being multiplied by itself once? And we see that that 3 is, so that leaves the radical as 1, and whatever was left inside stays. So our answer to the first question would be 3 radical 5. That's what the square root of 45 is simplified down into. All right, moving right ahead, then we have the square root of 75. Also ends in a 5, so we know 5 is a multiple. So I'll break it down into 5 and 15. 5 is prime, so that's done there. 15 gets broken down into 5 and 3. Both of those numbers are prime, so we can stop there. So the square root of 75 gets rewritten as the square root of 5 times 3. And in this situation, it's the 5s that are being multiplied by themselves. So that's what gets to leave the radical. And 3 is what's left inside. So radical 75, or square root of 75, gets simplified into 5 square root of 3. Moving ahead, those were the ones that most people felt pretty confident with. I think after, when we moved into question 3, 4, and 5 was where more of the questions started coming. So now let's look at the square root of 108. Now, it's an even number. It ends with a multiple of 4. These are all ways that we can already see that it's being broken down into a lot of different ways. You do not have to always divide by 2 to start. You can divide by any 2 factors you know. So when I look at 108, the 2 factors I immediately think of is 12 and 9. So I see 12 and 9. Neither of those numbers are prime, so I'm going to go ahead and break down 12 even more. 12 breaks down into 2 and 6. Could you have done 3 or 4? Yep, but I decided 2 and 6. So the 2 and 6 are there. And then 6 breaks down into 2 and 3. And those are the prime factors of that part. So then we break down 9 similarly, which breaks down into 3 and 3. So if I want to rewrite the square root of 108 into its prime factors, I'm going to rewrite it as 2 times 2 times 3 times 3 times 3. And in this problem, I'm going to go ahead and notice that there's a pair of 2's that can leave the radical as 1. So they leave, and then what's left is 3 times 3 times 3. So now I'm looking at this, and all I'm really looking for are pairs, right? Because we're undoing the squaring of something multiplying by itself once. So we have to only find pairs of numbers that can leave. So one pair of 3's can leave, but that third 3 is going to be remaining. So there's a 2 that leaves, a 3 that leaves, but there's still that lonely 3 left inside the radical. It's almost done, but the last thing we have to do is to multiply the 2 pieces together now to get it fully simplified. So the answer would finally be 6 radical 3. That is what 108 simplifies down to. All right, and then we move on to the square root of 196. 196 is not a number you deal with often. It's an even number though, so I know it gets divided by 2. I always just try to pick things I know pretty easily, especially if you have a calculator, it's easy to work with. 196 gets broken down into 2 and 98. All right, then 98 gets broken down into 2 and 49. Oh, and 49 we know something about. 49 gets broken down into 7 and 7. So 196 can be rewritten as the square root of 2 times 7 times 7. So we can now see that there's a pair of 2's that can leave the radical. So they leave as 1, leaving square root of 7 times 7 left inside the radical. But that's also a pair, so that can also leave the radical. So 2 is outside the radical, 7 is outside the radical, and nothing is left here. It's all blank. There's nothing left. So we can just ignore it entirely, and all we're left with is 2 and 7, which is just the number 14. No radical in sight because it's gone away. Everything has gone out of it. Now, you know probably all the perfect squares up to 144, right? 12 squared. The other ones are included if you can get all the way up to 15 squared. That's good to memorize. 196 is just 14 squared. The more you deal with them, the more you'll be able to identify them quickly. All right, moving on to the last one, which was the square root of 432. 432, big number, totally, but we can break it down a couple different ways. Yes, it's odd, yes, it's even, so I could break it down into 2 and something, but I happen to know that 432 breaks down into 6 and 72, so that makes it a little easier than continually working with like humongous numbers. So I'm going to take 6 and I'm going to break it down into its factors of 2 and 3. Both of those are prime, so I can stop there. And then 72, I'm going to continue to break down. 72 breaks down into 8 and 9. Neither of those are prime, so I'll continue to break them down. 9 is 3 and 3. Both of those stop there. 8 is 2 and 4, but 4 is not prime. Remember that 4 breaks down even further to 2 and 2. So this is a pretty big factor tree. Your factor tree might have even been even bigger. And the bigger they get, that's why I circle the prime numbers. It makes it easy to see which numbers am I dealing with. So I'm going to keep track. And I like to put all the numbers that are alike next to each other. So I'm going to put all of the 2's next to each other. I'm going to count. I have 1, 2, 3, 4 2's in this problem. So I'm going to do 2 times 2, 2 times 2 times, and then I have 1, 2, 3 3's. So I'm going to have the 3 3's there. 3 times 3 times 3. And here I'm going to go and I'm going to see if I can find all the pairs, see if we can go in less steps now. So I see a pair of 2's here, I see another pair of 2's, and I see a pair of 3's. So I know each of those can leave the radical. The only thing that's going to be left in the radical is this 3 right there. So one set of 2's leaves, the other set of 2 leaves, the 3 leaves, and the only thing inside the radical that remains is that 3. And then the final step would just be to multiply all of that. 2 times 2 is 4, times 3 is 12, making the answer 12 radical 3. That's the simplified version of the square root of 432. If you have questions, feel free to email me. Feel free to ask maybe if you wanted to do a Google Meet. I'm open to that. But we are going to need to know how to do this moving forward into what we're learning today. So make sure you don't let yourself get too behind if you're not understanding something. All right. Now you can make your way over to today's lesson if you haven't already done that, and you can work on that. Have a great day.